Hi, myself Harsha. I'm working on physical structure of bot. We inspired this design from Chandrayaan 3, where it is employed with AgroBOT system which has no space. We designed this bot using Fusion 360 software, and it is made out of aluminum which weighs very less and has more strength to weight ratio. It's a 6-wheel drive. It makes sure that all wheels are in contact with the surfaces even in uneven terrains, which is used for agriculture fields.
Hi, I'm Gokul. I'm going to explain you about torque calculations in AgroBOT. So, the bot weight comes around 15 kilos. So, when we take weight, we should not take directly, we should take a safety factor. So, we choose a safety factor 1.75. When we choose safety factor of 1.75, the bot weight comes around 26.25. So, total number of wheels in the bot is 6. So, when we divide that 26.25 by 6, we get a weight around 4.3 kilos. So these 4.3 kilos is the weight which is required for the motor. Each motor has to drive 4.6 kilos. So if we take the radius of the wheel, each wheel has a radius of 5 centimeters. So to calculate the torque, we have the formula of force into distance. So if we do the force into distance, so the force is equal to mass into gravity, and distance is 5 centimeters. When we do that, we get a value of 4.3 into 10 into 0.05, which is equal to 2.15 Newton meter. So this is the torque required for each motor. It shows a 240 Newton centimeters motor, which are DC pressed gear motors, which works with a 12 volts voltage and takes amperes of 2 amps at full torque. So these motors are ensured for each wheel. So there are 6 wheels, so we need 6 motors. To power those motors, we chose batteries operating 6000 mAh capacity of voltage 12 volts. The discharge current of the battery is 3C. We chose such a batteries of 2 such that we planned for AgroBOT to work for 1 hour. So the total current required for each motor is 2 amps. So the total current required for all 6 motors is 12 amps. So these 2 battery packs can give supply of 12 amps for 1 hour.
I'm Vinit, so I'll be talking about the AgroBOT's navigation system. So our AgroBOT operates in 2 modes. One is manual mode and another is autonomous mode. So for manual mode, we control our AgroBOT using this joystick. So what it does is, while controlling the AgroBOT across the field, it traces the path as coordinates. So when it comes to autonomous mode, our AgroBOT follows the saved coordinates and moves across the field. So we call this as breadcrumb algorithm, and also adding to the autonomous mode, it does not only move tracing those coordinates, it also comes back to its initial position.
In the joystick we can control the robot. So this is up button, back button, left and right. So I will show how to control the ball. Now we are not touching the controller, as we already traced the path. Now this will move automatically. YOLO object detection model to detect the ripened tomatoes in the field. YOLO object detection model is an open source model which not only detects the object in the frame but also gives the coordinates using a bounding box method. We trained this model using 640 different types of tomato images. So this YOLO model can differentiate between ripened tomato and unripened tomato. The AgroBOT is equipped with pesticide sprayer with a storage capacity of 5 liters. So the pesticide sprayer is connected to servo motors which can go up to an angle of 90 degrees to spray the top and bottom of the plants. The arm is designed using Fusion 360 with 3 degrees of freedom. The arm is made using PVC pipes and 3D printed PLA material. We used 25 kg CM servo motors to power up the arm and a finger-like gripper mechanism to catch the fruit onto the seeding operation. The arm is controlled via joystick. Along with the joystick, the arm can also be controlled via YOLO model. So the YOLO model traces the path traveled by the tomato and gives commands to the servo motors in the arm. Since it is not a 3D camera, we cannot get the actual coordinates of the tomato.
From the master node, the data is being sent to a real-time database using Firebase. Then the data from the Firebase is continuously updated to the farmer through an app that is made by us using Flutter, which helps us to make the app not cross-platform, not only for Android but also for iOS.
The future prospect of this AgroBOT is to implement fruit harvesting using YOLO algorithm. For this, we use the 3D camera, and then from that we'll get the XYZ coordinates, and we'll feed those coordinates into the code, and then which helps the robotic arm to move precisely to cut the fruit, and then it takes the fruits and it puts it into the bags.
The future improvements in the AgroBOT was to replace the aluminum with the carbon fiber to reduce the weight of the bot and to make it more light and to increase the payload to carry the fruits and vegetables. And we want to replace the motors with high RPM and high torque, having a more reliability like durability, having the to carry a payload. And we are using it. We want to integrate GPS for like return to home functions, and we are trying to remove the joystick control and we want to use mobile app application to control via phone, and you can control with the Wi-Fi and Bluetooth at a time.